All right, hello. Again, I am not Mr. Cunningham. It is me, Miss B. I'm going to go through the Unit 7 review with you guys. As always, try everything on your own first. If you are stuck on something, then look at your teacher's key or look at this video. But try everything on your own first. All right. For each of the following, identify whether the study described is a survey, experiment, or observational study. I know the quality is really bad, but you have this printed out from your teacher. Okay, a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played a video game they had never played before. The time it took them to reach a certain level was recorded. Okay, so I have two groups, but the people running the experiment or study are not forcing these two groups, okay? It's not, okay, I'm going to have a bunch of people show up. Half of you are going to play a different video game than the other half, okay? They are just observing, if I can spell. They are just observing the different ways that the boys and girls play. This researchers themselves are not forcing two groups, okay? As your statistics project, you collect data by posting 5 questions on poster board around your classroom and recording how your classmates respond to them. Asking questions, seeing responses, that is a survey. Okay, a professional sports team traded as best player, oh no. Local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number if they favored the trade, call one number if they favored the trade, and a different number if they opposed to the trade. At the end of the news program, they announced 53.7% of callers favored the trade. Okay, I would say that this is an observational study. Okay, I could definitely see it being called a survey as well. I feel like I would take either one. I think survey better fits actually, now that I'm thinking about it. Whoops. I think a survey, because you're asking a question and getting people's input. It's a survey for sure. What am I talking about? Local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 stretches of road and paint B to the other 10. And they discover that paint B lasts longer. Okay, this is definitely an experiment. Okay, we're taking 2 groups and applying different scenarios to each group. This one's observational because we're having the 2 groups still do the same thing, right? But this one, I'm giving 2 different groups different conditions, 2 different paints, okay? National Highway Traffic Safety Administration conducts annual studies on driver seatbelt use at a random selection of roadway sites. To determine if seatbelt usage has increased, data is analyzed, okay? That is definitely an observational study. Cool. United States Senate has 2 senators from each of the 50 states. That is true. Select all methods that would select a sample of 10 senators at random from the entire Senate. Okay. At random. Take the 10 senators from the 5 largest states. Definitely not random. You're favoring the states with the highest population. 10 senators who have served in the Senate the longest, not random. You're going to get the 10 oldest people in the Senate. Place the names of all 100 senators on slips of paper, place into a bowl, mix them up, and select 10. Heck yeah, that's pretty random. Okay, some people in my classes have been saying, like, what if someone's name is really long? Okay, they're all equally sized pieces of paper. Send letters to all 100 senators, select the 10 that reply back the quickest. That is not random. Replying back quickly says something about someone's personality. That's not a purely random thing. It may not seem like it's biased, but there are definitely other factors influencing that decision. Okay, number senators from 1 to 100. Use a random number generator. Make a list of 10 random integers. Yeah. Okay, it's the same thing as the papers, but instead of drawing names, you're drawing numbers and like comparing the number. Okay. Cable news show displays the results of a poll for two-candidate runoff election between candidate A and B. Poll shows candidate A is leading with 51.5% of the vote, but at the bottom of the graphic, it says plus or minus 2.5%. What does that imply about the actual percentage of people who will vote for candidate A? Okay, the actual percentage may not be 51.5, right? This that they're reporting is the margin of error. All right. So what does this imply? Between or somewhere between okay, let's take 51.5 minus 2.5 and plus to get a range. I get my calculator. $49 and 54. Somewhere between 49 and 54% of people will vote for candidate A. I'm cutting off. Okay, there's my work showing it. All right, so remember, the sample, we use this sample value as an estimate for our population proportion, okay? But it's not guaranteed. That's why we report with a margin of error, okay? The scientist captures 100 water samples from each of 100 different locations along the Mississippi River, records the proportion that are contaminated with bacteria. I like to underline like the key part. Like a lot of this stuff is just like a lot of extra context. The scientists found that the mean proportion was 65 with a margin of error of 10. I like to write this out in my handwriting because I feel like it stands out better than around the other text. Okay. And margin of error, sometimes I write mo, 10%. After the study was published, another group proposes to run the same test. Oh, and this one's 100 samples. That's kind of important too. Same test, but with only 50 water samples. So which one will be true about the second study? Okay, the more data you gather, the more accurate it will be. Do you agree? The more data you gather, the more accurate. The more accurate your data, the smaller the margin of error. Okay, so more, I'm going to kind of write that down. More samples, more accurate. So that would give me a lower margin of error. Okay, so this one is fewer samples. So that margin of error is going to be greater than 10 because it's going to be less accurate. One sec. All right. A normal curve with a mean of 250 and a standard deviation of 15 is shown to the right. Here's my mean right in the middle, right where I'd expect it to be. Standard deviation is 15. So shade the region within 2 standard deviations of the mean. Well, 2 times 15 is 30. So I'm going to look both 30 above the mean and 30 below the mean. Okay. Shade, shade, shade. Within means in between. Shade, shade, shade. Okay. What percentage of the data is shaded? Within 2 standard deviations is always, 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 always 95%. 95%. And your graphic calculator. All right. So a lot of this information I'm going to need from my graphing calculator. So got this one here. So when you have a dot plot, this means there are 3 data points with a value of 0. Okay, so I'm going to go in my stat menu, hit enter to edit. Okay, then I'm going to have 3 zeros in there. So 0, 0, 0. Looks like there are 6 ones, 4 twos, 2 threes, 4s, and a 6. Okay, once your data is all in there, go back to stat. I'm gonna go over to calculate because now I want my calculator to calculate for me. Enter, enter, enter. Bam. Okay, that first value here, I'm gonna try and zoom in so we can see really good. X with the line over it, that means the mean. Okay, so my mean is 2. Standard deviation is this one, the circle with the line. That's the Greek letter sigma. So standard deviation is 1.59. Median, you can see there's this little arrow here. That means go down. I'm pressing the down arrow. There's more. And we can see median is also 2. Okay, for mode, your calculator won't tell you the mode, but the mode is just your most common value or the most repeated value. So to me, that looks like number 1, right? I have 6 data points at number 1. So the mode is 1. Right. A set of test scores is normally distributed with a mean of 83 and standard deviation of 5. Find the proportion of test scores all here. Okay, I'm going to draw a really quick sketch. Okay, 83 is right in the middle. My standard deviation is 5. 1, 2, 3. I have to make this a little bigger. A plus 5 would be 88. Plus 5 more, 93. And then 98. Minus 5 would be 78. 73. 68. Okay, so those are kind of the values that I have in mind. Here's my mean right in the middle. Okay, so greater than 88. I'm going to draw a picture with a little bit less detail now. Here's my mean. I know 88 is exactly 1 standard deviation up. So greater than 88 would be shading this whole section. Okay. There's a couple different ways you can think about this. So I know that this part within 1 standard deviation of the mean is 68%. Okay, so one way you can do this is say, well, 100% minus 68 is, what is that, 34? What, 32? What am I talking about? Should be 32. Okay, so but both of these ends together would be 32. Then you can divide by 2 to get just this upper part of 16. 16%. Another way you can think about this is if this whole thing is 68, that means that each of these sections is 34. Okay, and the mean sits exactly at 50%, this mean. Okay, so I can shade all of this would be 50. So 50. All of this part would be 34. So unshaded is 84%. Then you could take that 100 minus that 84 is 16%. Do you want to say hi? The algebra 2. Yeah. Mr. Pozo's hiding from you guys. Hello. Okay. This stuff is kind of not that easy sometimes. You really need to remember all this stuff, that exactly halfway is your mean, and then our 68%, 95 are essential. Okay, so but let's look at this one. Between 76 and 96. Do you see those two numbers anywhere here? No, neither of those numbers are on like perfect standard deviation lines. So we are going to have to use our calculator here. So instead of going into the stat menu, see how it says distribution right here? We have a normal distribution, so press second, and then vars. We are going to go down to the normal CDF. Okay, they're saying between 76 and 96, so 76 to 96. My mean is 83. That's another Greek letter, it means mean. And standard deviation was 5. Those I got from my problem statement. So enter, enter, enter. Bam. 0.915. Or you can say 91.5%. Okay, what about less than 70? Again, I don't see 70 on this sheet or on this distribution. I know it's somewhere here, right? So when they're saying less than 70, they want that little bit. Okay, so I'm going to go back into the distribution to normal CDF. If I want less than 70, that means my highest number is going to be 70. So my lowest number needs to be something really, really, really small. I like to even do like negative, and we can do negative like a trillion or something. Something really, really, really small. Okay, because this just says less than 70. So I don't want to put like 60, because 60 to 70, I want something really, really, really small all the way up to 70. Okay, same mean and standard deviation. So enter, enter. Oh, that is small. 0.004. Something like that, which I guess is move your decimal place twice. This is 0.5%. Not even a whole percent. Okay, if that had said more than 70, let's kind of do one off to the side here. More than 70, I would have had 70 as my lower and some really, 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 really big number for the upper. Okay, 995. A researcher is interested in whether practicing yoga will improve hockey players' performance. Researcher decides an experimental study is best to answer this question. One group will play a game without practicing yoga, and a second group will follow a yoga routine. Okay, during the game, they're recording stats of each player. Why is an experimental study the best way? I'm trying to decide if doing yoga makes them better, right? So just observing, I bet not a lot of those players are actually doing yoga before games already. So why is an experimental study the best? We want to see the effect of two different scenarios. In general. All right, so now they're giving me some data. I'm just gonna split this up to kind of keep myself organized. Okay, mean number of goals for players who did yoga. Here's the mean. Here's the standard deviation. Ones who did not do yoga, here's the mean, and here's the standard deviation. Okay, in each case, find the probability a randomly selected player has more than 2 goals. Okay, so again, let's go to our calculator, because 1.9 plus 0.2 is not exactly 2. So this 2 goals does not sit precisely on a standard deviation marking. Okay, so the ones that did yoga go into our normal CDF. We're looking at more than 2 goals. So 2 is our lowest, and our upper is just something really, really big. Okay, the mean is 1.9, and standard deviation is 0.2. Okay, so the probability, that's the same. Some people have been getting tripped up on that. That's the same as asking about the proportion. Okay, so the probability that a player who did yoga scores more than 2 would be about 30.9%. Or you can report it as the decimal as well. Okay, the ones that did not do yoga, go back to your normal CDF. Same thing, I'm looking at more than 2, so I have 2 as my lowest and something really big as my highest. But now the mean is 1.8 and standard deviation is 0.33. This one's 27.2. All right. If you end up taking AP Stats in your lifetime or statistics in college, you'll learn about how to tell if this is a significant difference or not, because they're pretty close, right? A biologist is breeding fruit flies to analyze a specific genetic mutation. Biologist captures a random sample of 50 fruit flies, tests them to find out if they have the mutation. In this sample, 10 of them did. Okay? Using this information, this one's kind of like in the book where they had to like kill the flies to test them, so they don't want to just keep taking more and more and more and more samples, right? Because we know more samples makes things more accurate, but we don't want to keep killing flies. Okay? Using this information, the biologist uses simulations of additional samples with the same proportion. Okay, and he finds that the standard deviation is approximately 0.015. So instead of having a lot of different samples, they're taking one sample and then randomly simulating samples, kind of like we've been doing in class these past few weeks. Okay, what is the proportion of genetically mutated flies? Well, 10 out of 50, right? So that's what, 0.2? 0.2. And provide a margin of error. Your margin of error, or MO, is always 2 times the standard deviation. So 2 times 0.015. I like to use the calculator on these videos because how embarrassing would it be if I messed up and then it's for all the Algebra 2 students in the whole world. Okay, why did the biologist run the simulations to find additional possible proportions? We can't say that like one answer is for sure for certain. Okay, so running more simulations and stuff could potentially get more accurate data, or like to test the variability and get a margin of error. Okay, if you only have one data set or one sample, you're not going to have a margin of error because you don't have anything else to compare it to. So you need to have like a bunch of different data to get standard deviation and find your margin of error. Okay, last one. Student measures height of 40 local dandelion specimens selected at random. I bet they were in my front yard. My dandelions are crazy. Sample mean is 2.35 inches. Again, sometimes I just like to write it off to the side so I don't lose it in the text. Margin of error of 0.55 inches. All right. Based on this information, what is the range of plausible values for the mean heights of the population of local dandelions? So plausible values, I'm not talking about everything that is possible, because we did the one example in class where we flipped 20 coins, and it is possible for all 20 of those coins to land on heads. But is it plausible? Like, would we expect that to happen? No. So it's good to have a range of plausible values. So to find that, I'm just going to take 2.35 and add or subtract, or I like to subtract first, that margin of error. Okay, that margin of error gives us a range that we are 95% confident that the actual value falls within that range. I'm just typing in my calculator, don't mind me. Okay, so the range of plausible values, I would say between 1.8 to 2.8 inches. There you go. Good luck studying for your test. Like, comment, subscribe. See if I can get more views than Mr. Cunningham. Jakira, do you think I'm going to get more views than Mr. Cunningham gets? She said maybe. Good luck.